Hey everyone, I'm Sanit Rawat and I'm back with another video. In this video, I'm going to explain the remaining solutions of second internal, the remaining 20 questions which were asked in the second internal of fourth sem numerical analysis and design under the guidance of Dr. Shaligram Prajapat. So let's get started with it. Uh, just let me get this right. Um, these were the MCQs which we discussed in the former slide. Let's go ahead. Yeah, these were the remaining MCQs. Let's start with the 21st question. Which of the following is an example of Gaussian quadrature formula for numerical integration? Going by the options, yeah, Gauss-Legendre quadrature is our option. Let's move on to next question. Which of the following is true regarding the weights and the abscess of the following used in Gaussian quadrature formula. So here we know that in the Gaussian quadrature formula, the weight and abscissa are of the exact same order. So we have that mentioned in option number A. So option number A is going to be our correct answer. What is the order of accuracy for Simpson 3 by 8 rule? In Simpson 3 by 8 rule, we take the value of n as 3. So the order of accuracy becomes 3 as well. Going by the option, C is going to be our answer. Question number 24th. Which of the following is an example of composite integration methods? Um, so, except the Simpson rule, trapezoidal rule and Gauss-Legendre quadrature are both an example of composite integration method. Hence, both A and B are going to be our answers. What is the drawback of using high-order Newton-Cotes formula? Um, in the previous video, I have already experienced that if we use a high-order formula, the complexity can increase way too much. The memory required can increase way too much. The chances of error are also increased drastically. Hence, going by the options, uh, option B clearly mentions that they also require more function evaluations. Hence, option B is going to be answered. Moving on to question number 26, which of the following is true regarding the abscissa used in the Gauss-Legendre quadrature? Um, in the Gauss-Legendre quadrature, the value of the distance, just a second, yeah, the values are located at equal distance. So hence they are equidistant. Now moving on to the next question, which of the following is an example of an open Newton-Cotes formula for numerical integration? Mm, Simpson's rule is the example for that, and trapezoidal rule is not. So yeah, going by the option, we have D, both B and C. What is the forward difference operator? Uh, the forward difference operator is used in performing the Newton forward interpolation. It is used to find the value of the uh, next neighbor, the next true neighbor. Hence, going by the option, I think A is correct because it is clearly mentioned that it approximates the derivative of a function using the value of a function at two neighboring points, which is basically the definition for forward interpolation. Let's move on. Um, what is the backward difference operator? Again, backward difference operator, it is used to estimate the values of a function when we have two different set of values given. And yeah, it is used in going from last to the start, as I've mentioned in the previous video. And again, option A clearly explains all of that. So it is mentioned it approximates the derivative of function using the value of function at two neighboring points, exactly similar to the last question. Moving on to next question. What is the divided difference operator? So the divided difference operator is used to derive multiple difference points, uh, and here we have Option uh, Option A. It is used to approximate the derivative of a function at a given point uh, for the function at multiple neighboring points. 31st. What is the shift operator? Yeah, shift operator is just used to shift the value to left and right so that it helps us in better understanding and approximation. Mm, Now, what is the order of accuracy for Simpson one-third rule? Here again, the value of n is taken as 2, so the order of accuracy becomes 2 as well. Moving on. Which of the following numerical integration methods is based on the use of forward difference operator? Forward difference operator is clearly used in Newton's forward interpolation, trapezoidal rule. It has no utility. Simpson rule, again, no use. Midpoint rule are completely different. So yeah, definitely D, none of the above. Which of the following numerical integration methods is based on the use of backward difference operator? Backward difference operator, again, it's based on Newton backward difference. So we have the same options, and again, the answer would be none of the above. Which of the following numerical integration methods is used for central difference operator? Again, almost the same question. Central difference operator is not used in any of the three options that are given here. So again, we'll have none of the above. Which of the following numerical interpolation formula is based on the use of divided difference operator? Going by the options, we have Lagrange's interpolation, Hermite interpolation, divided difference operator. It is used when we have equal intervals. Equal intervals. Lagrange interpolation operates on unequal interval. Hermite's interpolation is just an advanced version of it. So yeah, Newton's divided difference formula is going to be the answer. Moving on to our last four questions. Which of the following numerical interpolation uses polynomial interpolation? So, as I mentioned earlier, the Hermite interpolation is just the advanced version of the Lagrange interpolation. And here, the polynomial interpolation is used by Lagrange interpolation. I also explained this in the previous part of the second internal that the polynomial interpolation is used by Lagrange's methods. And let's move on to the last three questions. Which of the following numerical interpolation formula is used for interpolating a function with both its values and derivatives at a given point? So again, it's been explained clearly in the previous two questions that here we use Hermite interpolation method. Hermite interpolation is an advanced version of the Lagrange interpolation method. It operates on an unequal interval, and uh, it is used to interpolate a function with both its values and derivative at a given point. So option C is going to be our answer. Question number 39. Which of the following is true for numerical integration methods based on higher order polynomial? So let's read the option first. They are more accurate than those based on lower order polynomials. They are less accurate than those based on lower order polynomials. They are equally accurate as those based on lower order polynomials. So if we use a higher order polynomial, we use it to increase accuracy. And option B mentions that the accuracy is less than those based on the lower order polynomial. So it's definitely not true, and option B is completely eliminated. Option C mentions that they are equally accurate as those based on lower order polynomials. I don't think this option is true either because uh, the whole point of using high order polynomial is to increase the accuracy. So yeah, option A goes by that, and hence option A is correct. Jacobi's method is known as displacement method. No. Simultaneous method. No. Diagonal method. No. Yeah, option B is correct. Simultaneous displacement methods. Thank you for watching both the parts of first and second internal explanation. I hope you really understood what I was trying to explain. Uh, Thank you for devoting your time. Wishing you all the best.